Cardiovascular adaptations and respiratory adaptations. Now it's time for muscular adaptations. So we have two objectives. It's the same as the last two lectures this time, but they're like the others. This is directed at, in this case, muscular adaptations. So when we go through aerobic training, there can be there are changes to the fibers, okay? And so type 1 muscle fibers experience hypertrophy. Okay, type 2 don't experience the hypertrophy due to aerobic training because they're not being used. Remember, aerobic training, we're using its endurance, we're using oxygen, okay? Type 1 fibers, they need the oxygen. We use them relatively low intensity, whereas type 2, this is higher intensity, short duration, but they're not really involved in an aerobic capacity. Now, generally speaking, doesn't appear to be any change in fiber type. If it does exist, we might be able to change or convert type 2X into type 2A. In other words, we're taking something that's completely glycolytic and now we're making it a little more oxidative. Okay, but where the real changes start to come are here. So with the capillaries, we increase capillary density. Okay, and this is probably a big reason why VO2 max occurs, why we can increase it. We talked about how cardiac output increases in the cardiovascular part. Well, that's great that we can deliver more blood, which means we deliver more oxygen, but we have to be able to get that oxygen into the muscle, and the muscle has to be able to use it. So, because otherwise it doesn't matter if we've got a lot of oxygen if we can't use it. And so by increasing the number of capillaries, we can get more oxygen into the muscle. This ties in wonderfully well with myoglobin. Okay, as we've talked about in the past, oxygen binds to myoglobin, and myoglobin basically shuttles the oxygen that enters the muscle cell and gets it to the mitochondria. Okay, this is important as we go from rest to exercise. With training, we can actually increase significantly the amount of myoglobin that is in our muscle cell, and as a result, we're able to get more oxygen to the mitochondria. It's not enough to have the oxygen in the muscle cell. We need to get it to the mitochondria. It doesn't need to go to the lysosome or the centriole or the endoplasmic reticulum. Where we really need to get oxygen is to the mitochondria, because that's where we can use it to create ATP. And so the myoglobin help with that. Training also does some things to mitochondria. First, we'll just increase the number of mitochondria. Think of mitochondria as our factories. If I've got more factories, I can produce more of, in this case, ATP. If I've got bigger factories, I can generate more ATP from each factory. And so training causes my mitochondria to increase in size and also increases the number of them. And it also causes new mitochondria to be created. And just another way to think about this is, generally speaking, new factories are better, more efficient than old factories. Okay. Along those lines, we'll start creating more oxidative enzymes. Okay. And this will allow us to take advantage of the oxygen and use it to create ATP. And so we'll have the correct enzymes to go through these oxidative systems.